First things first, I do want to say is this. I want to ask, what questions do you have about how to write this factored form? Looking around the room, all the groups have gotten the factored form, but individually, does anyone want to or need to ask a question about that factored form? Seems like we're okay there. I do want to point out there are two different methods that we can traditionally use. Shadidra and her group was talking heavily about the idea of the zero product property, right? What we literally know is that in this first case, x equals -1, and if I use the zero product property, what does that actually have to equal? 0. So what can I do to -1 to make it a 0? Let's just add 1, right? X plus 1 is one of my factors. What I always want to encourage is, I always remember my factored form is x minus r1. X minus r2, x minus r3. And I don't have the individual linear factors to write something different, so that's how I would have thought about this. Either one perfect, right? Make sure you're explaining those ideas as you're doing it. So x plus 1, x minus 2, x minus 3, x minus 4. More than likely, you're not guessing that right. But if you write x minus r1, and x minus r2, and x minus r3, is that clear evidence to me that you understand why that's the factor? If you write this out, is that clear evidence that you understand why this is my factor? So remember, it's about evidence of understanding. There was a debate for quite a few people about what the a value would be. But Elizabeth, what did we talk about we would need in order to figure out what a actually is?
Another point.
You would need another point, okay? Otherwise, is this acceptable? Yeah? Would this be acceptable? Would this be acceptable? I just said it needed to have those zeros. It can be any polynomial with those zeros. So all of those options would be correct. I would make my life easy and make the a 1 personally. I'm all about making my life a little bit easier as much as possible. Without cheating myself of a good education, that is, obviously. Now, before y'all continue, because I see some groups have already started getting to the later bits, and I love that detail. But before you can continue here, I do need to ask, have you made sure that your standard form and your factored form are the same function? And I told one group, I have no clue what the final standard form is. How could you check to make sure your standard form and your factored form are the same? Graph it. And they need to what? There's that beautiful mathematical language. Nice. They need to map to each other. So please take the time to graph your standard, graph your factored form, make sure they map to each other. That's a phenomenal strategy for you on assessments. Because, okay, you made a mistake, you check yourself, and you're like, man, Mr. Kinney, I don't have time to go back and fix it or find my mistake. That's fine. Note, hey, I know there's a mistake here. And if you have time at the end of the assessment, come back and fix it. Remember, I want to see everything you do understand. All right, so check your answers, check your standard form before we move on to degree and all that stuff. All right, so let's get going. I want to on this here, looking around the room, I got to go ahead and say, there's not much feedback I need to give. We're doing a phenomenal job with this, and so really want to applaud you on this. Looking around the room, everyone said, thank you. Yeah, there you go. Okay. So a couple of things, just a couple of notes that I do want to point out to help speed some things up. First off, how did we know this was going to be a 4th degree before we even wrote the equation for this? There were 4 zeros, right? Before I even wrote an equation, there were 4 zeros. I knew it had to be 4th degree. And so before I even wrote an equation, created a graph, why did we know there's going to be a possible 3 extrema? Right, well, now remember, the degree minus 1 is the max extrema, right? So it's possible, but it's just maximum. What was another option? We didn't have it here, but what was another option? Only how many? 1, right? Remember, our extrema are coming in pairs. So it could have 3 or it could have 1. Now, the only thing that I want to encourage, actually I'm going to talk about the graph in a second. So I do want to point this out. Over here, if y'all can scoot really quickly. I just want to point out there's 2 different major ways that we could use the area model here. And most of y'all use one way, but I do want to encourage you to do this as well. Notice this group, y'all took 2 of the factors, x plus 1 and x minus 2, got its standard form, and then you took that standard form and did what with it? and then multiply it by x minus 3. So you took multiple steps, right? So they took their x squared minus 1x minus 2, multiplied by the next factor, x minus 3. Then you took that standard form, right? And that cubic, and multiplied by x minus 4 and got standard form. Notice, they got the same exact answer most of y'all did, but what did most of y'all do?
Both standard form. And multiply.
So y'all did, most of us did pairs, right? We paired these up, we paired these up, so that's just something for y'all to learn from. It's another strategy. And then notice they took the two quadratics to figure out the quartic. Do they both work? 100%. Does it matter which method? No, I'm not sweating. I just want you to be aware that there's more than one option. Like using the area model to help you distribute is the priority there. I want to teach you important principles that you apply how you want. There's one thing I want to talk about the graph, but before that, I want to talk about this. And this is a final thing that most of us did really well of not doing, but I do want to point out, and I want us to learn from this beautiful mistake right here. Not kings, somebody else, and not queens, because they might have heard me talk about this. What do I not like about these? Why are they circled? They're too straight. What's the problem with those being straight? They're not what? Say it louder, Elizabeth. It's not just that they're not here, it's not a function, right? Notice I was able to draw a vertical line, and that one vertical line hits how many points? It should only hit one, but how many is it hitting? Infinitely many. Remember, what is a function? One input maps to one input maps to only, or one, and only one output. Remember, we need to consider the idea that these are functions, and so we can't have vertical pieces of these graphs. Even when it gets really steep, it's still moving out and up, right, or out and down or something. So please be careful about that. Does that make sense? We go with those ideas? Okay. Now, I'm going to use this graph up here. This is the final details I'm going to point out. Sorry for y'all's draft. It's beautiful. I just want to point this out. Most of us, I think, used our calculator to get the graph of this function. And I'm going to go ahead and tell you about a couple of things that I'm going to be changing, if this is okay with y'all. And I'm going to be honest, I'm assuming it is. But what I'm thinking about doing is changing things up so that we finish our unit on polynomials, the last few details today. Demonstrate understanding to start class tomorrow. Friday, when I'm out of school, there's a Mathia assignment that has practice with all of these things, which I apparently left locked and didn't realize until last night. It's unlocked so you can work on it. You'll work all day Friday on that practice to review for the test, and then I actually have to be out again next Wednesday to lead some more professional development for teachers. So taking our test on Wednesday. We'll review a little bit Monday, Tuesday, but mostly we'll move to that next unit, test on Wednesday, so you have that extra time to prepare. Does that make anybody angry or upset with me? Drake's like, nah, Mr. Kenny, the bed, let's go.
So you can teach other teachers?
Sometimes, yes. I'm also the student of other teachers too, but yeah, I lead a good bit of professional development for other teachers. Are we okay with that option?
So test Monday?
Remember, I'm going to be out again on Wednesday, so we test on Wednesday.
Okay.
Okay, but that gives you all day on Friday to work on a Mathia assignment. That gives you the weekend and things like that to work on the Mathia study. And what I'll do is to review for the test, just 10-15 minutes at the beginning of each class, Monday, Tuesday, where you ask a question via the bell ringer, based on check your understanding, anything to improve your understanding. Yes, sir?
Is that Mathia complete grade?
Yes. You got an hour and a half to work on it in class. It is an assignment that takes longer than an hour and a half, according to Mathia, but they usually use it as a learning experience. We've already done all the content, I will say that, so it shouldn't take terribly long, but if you don't finish it in class, like one, the expectation, I can see how long you work on it in class, I can see the amount of time logged in and what days you log in and stuff like that. But if you don't finish it in class, then you finish on your own time before the test. It'll help you prepare for the test for sure. All right. Sorry, this is the reason I was thinking about that is because of this assignment. So like right here, I want to point this out. We have these zeros, and the goal is to understand polynomials well enough at this point that I don't even have to have the factors graphed. I don't have to have the calculator. Once I have my zeros and I know some key features of this polynomial, I can sketch this polynomial. So like looking at this polynomial, having those zeros, what do I know instantly about this function? Okay, so I know my y-intercept, sweet, that was negative 24, I think. Okay, so we do know that right here. What else do we know about this function? The ends are going up. So you're thinking about that quadratic, concave up, the ends are going up, right? So there's more than just one concavity in this function, but we want to think about end behavior, right? We want to think about those things instantly. It's even degree. So what does that tell us, Bella, if it's an even degree? What does it tell us about the end behavior? They go the same direction, right? Hope, would this be both going up or both going down? You had to look at your graph, but how should we know without looking at the calculator, without looking at the graph, that they're both going up? So remember, even just tells us they're the same.
You do know, we just talked about it.
Okay, okay, so what tells us, Brianna, if they're both going up or both going down? So don't forget, the leading coefficient is that final detail, right? Leading coefficient is positive, leading coefficient is negative. If it's odd degree, overall that's increasing, so that leading coefficient is positive, and this would be leading coefficient is negative. That's in the Matthew assignment as well. Like, there's a whole bunch tied into that for practice if we're struggling with that detail. So this one, they're both going up. I know that. And now, things can change if we have a single root, triple root, quadruple root, double root. I don't know why I skipped that one, but I did. But like, what type of roots are all of these?
Single.
They're all single, so what do I know has to happen at that root?
Gotta pass through.
It's got to pass through, okay? And so, it's got to pass through to get back to here. That's a single root, so what's going to happen?
Pass through.
It's got to pass through, and it's got to come back to
Pass
here,
through.
and then pass through. And so if we understand single and double roots, the rest of this becomes pretty straightforward. What questions do you have? Go once, go twice. So, okay, I want you to take time to put whatever notes you needed to. I know several of us have already been working on number 2. If you finish your answers to number 2, go ahead and start on number 3 on the board. We did not do all of 3, we just looked at the intervals of increase and decrease. So kind and considerate.
Where's your Bible?
Thank you, guys.
Oh no, I might not be.
It's going to be on page 260, or no, it's still on 263. It's just the bottom of that page. It was 1. However, I want you to look at these again. What do we have? Are we just told what the zeros are this time around? No, we're given a graph, aren't we? And what does that graph have on there to help us figure out what A is? We got lots and lots of points. Does it matter which point you choose? No, but you got to take the time to figure out what A is. I would take the time to figure out what A is. You pick whatever point you want and use that input and output. One thing I just want to encourage you is you don't have to erase. I'm going to open the floor for you to ask what questions you need, but collectively as small groups, as far as I can tell around the room, we're all getting the same answer, which tells me what?
We're all right.
We're all crushing it. I actually just saw one thing I want to talk about and be careful about, but yeah, overall, it seems like we're making sense out of this. Are there any questions you want to ask based on like, hey, we came up with this as a group, but I'm not 100% certain. I want to ask about this detail. Miles, what's up?
So them shit to understand all this stuff, that be
Now when I look at that domain and range y'all wrote up there, have you told me why that's your domain and range? Or did you just make a claim?
I looked at the graph.
Thank you. But is that a claim, or is there evidence with what you saw on the graph to think that? So here's the thing. Let me point it out this way. You are stating the domain is negative infinity to infinity, correct? That's a claim, right? And that's all you said. Have you given evidence for why it's negative infinity to infinity? No, it's not. No, sir.
Wait.
We're about to study this function right here.
What'd you say?
Next unit. We're studying, actually, next unit and a half, we're going to study this function right here.
Every polynomial, that one makes sense.
Okay, so could you write down every polynomial has a domain of negative infinity to infinity? That could be evidence of understanding.
So what
But we're going to get into functions like this that are not negative infinity to infinity for the domain.
I got another question. What the range began?
Well, that's what we're about to talk about in a second, so hold on to that. But again, I want to remind you, so like, you've given me claims, you've made this statement, but if there is no work, if there is no explanation with how you got there, and it doesn't have to be super detailed, like sometimes it's just a matter of circling points and pointing, hey, this is what I looked at. But if you don't have any work or any explanation to go with it, there's no evidence.
Okay, so
It's just a claim.
And draw arrow. And zero.
It depends on, here's the thing, it's like, yes, it's details, but how strong of details is it? Is it enough for a clear, consistent, and convincing evidence? Is it just clear evidence, or is it developing evidence? Because it's some details, but not a lot. So like, that's what you want to think about. Like, don't try to do the least. I will say, like, I've mentioned Elizabeth, if you ever want to look at one of her assessments, she does phenomenal going over the top. Like, I love it, right? But you don't have to go to that level, right? A CCC, clear, consistent, convincing evidence, that's the goal. A lot of times Elizabeth has CCC plus on there because that's when you go full detail and then go even a little extra, right? So more detail though is the only thing I would say. I think you understand domain and range, but without more explanation, I don't have clear, consistent, and convincing evidence. Okay? So the only thing I want to talk about, be careful with the in behavior. Oh, that's still frozen, so that's the last problem. Right here. So I need to remind you, sorry for whoever this is, phenomenal work, but it's got to go by. Right here, remember there's a left-hand side of the graph and a right-hand side. On the left-hand side, what is x approaching? Negative infinity, okay? Everyone actually got that correct. But on the right-hand side, what is x approaching? Positive infinity, okay? I just saw one group over here, maybe I think, where you had two negative infinities for x. So remember, x is going to the right, it's going towards infinity. Notice, like, and this is simple evidence, or details, right, Miles? But like right here, me literally putting left-hand side right here next to the graph and drawing an arrow, you're telling me why you think x is negative infinity, or x approaches negative infinity.
So this works?
I'm looking at that part, but see how I'm like saying that just circling this and noting these small things, like if I want better evidence, write something, right? But that's evidence for why x is going to negative infinity. A simple arrow to the left. Putting my in behavior right there. That's simple evidence for why x is going to negative infinity. So as x goes to negative infinity, what's y going towards? Going up to infinity. Notice again, arrows just showing the directions, right? As x goes to infinity over here, y goes to infinity. And especially if I just give you the equation, you need to try to draw those in behaviors as part of your evidence for why you're saying what it is. But it's not evidence of understanding. Okay? I think for the most part we all got that. We all got degree 4. Domain and range, we already had that whole discussion. The domain of all polynomials is what? Negative infinity to positive infinity. But also looking at the graph and explaining, hey, the minimum x, like literally, you can do this as evidence of understanding. There's my minimum x, right? It never quits going left. It's a negative infinity. Does it ever quit going right? So the maximum x is positive infinity. Whew, there we go. Like minimum x, maximum x. First off, by referring to x, I know that you understand domain is all about the x. Second, I now understand or can clearly see that you understand the minimum x is negative infinity, the maximum x is positive infinity. That's evidence of understanding. It's not just randomly writing stuff down. In a similar way, if I ask for range, what's the first number always got to be? Well, sorry, not always. But what's the first number in that interval notation? By the way, don't forget, it's called interval notation. This is everything from negative infinity to infinity. But range, I'm referring to the y, thank you. And I need which y value first? Well, it's always the minimum. Whatever the minimum is, that's what always goes first. And what was that minimum that we see a couple times? -4. And what's the maximum y? Infinity. It never quits going up. Now we'll point out, what would we call these extrema right here? I don't think it actually asked for that here, but it should have. What would I call these extrema? I would agree, but I would call them something else as well. Are there any y values below these points? So they are relative minimum, right? It stops decreasing and it starts to increase. But also, those are absolute because there's no y values below them. Absolutely none. Those are absolute minima as well. And what would I call this? Relative maximum, right? It stops increasing and starts to decrease. That's also, remember, what defined our intervals of increase and decrease. I didn't go over that because we already did that yesterday? Yesterday, I think. It will be on your next demonstration, understanding those, so play with that, practice with that. That is the last set of check your understanding questions. Is also very heavily, there's like a whole section in Mathia where every question's about intervals of increase and decrease, so that'll help you practice there. Any final questions before we look at the last concept for this unit? Okay. Why is this one not an absolute maximum? So you understand why it's relative, right? Stops increasing, starts to decrease. Now remember, when we say absolute, we mean it is the absolute highest or lowest point for the entire function. And this one's pretty high, right? But aren't these y values above it? So it can't be an absolute maximum because it has y values above it. Are there any points below here? That's why it's an absolute minimum, right? So absolute means it is the absolute highest for the entire function, nothing's above it, or it's the absolute lowest for the function, nothing's below it. And I will say this, you can only have one type of absolute max or min with these types of functions, right? Because they're either going to, so first off, with an odd degree, remember we've talked about it, can you ever have an absolute max or min with odd degree? No, right? It's because it's going to go down forever, it's going to go up forever. And with an even degree, it's going to be either up forever or down forever, so you can either have an absolute minimum, or if it's going down forever, you can have an absolute max. It's only one of the types that you can have, though. So good question. If you want to get these candy later, yeah. Yes, Jade.
I thought there was one absolute experiment.
So, and this is why I think the way I said it is that's kind of true, because these are the same y values, they would both be absolute. Does that make sense? So that's a good question as well. The question really is there a y value below it? It's okay for a y value to be the same. Because remember, and I guess I should reemphasize this, it's an absolute minimum value, right? When we say value, what type of value are we talking about?
Y.
So the output, right? The y value. And what is the absolute minimum value? The minimum value is -4. That -4 just happens twice. And that's why I emphasize, I don't just write points, I say the absolute minimum value or minimum of -4, and then I indicate where it's located. So that minimum value just occurs at 2 different spots. Does that help clarify it? That's why I like that notation better than just individual points. Would you agree with that, Mr. Hobby? Yeah, okay. So it's more about the output and it's just at an input. So notice that way it is still just one minimum, absolute minimum. Yeah. Great question. You can get a piece of candy too if you want later in a second. All right. Any other final questions? No, skipping this, we didn't get time. Why are you acting weird? Work! There we go. You broke it. Okay, so we talked about this yesterday. Average rate of change. What keywords did you think about every time you hear average rate of change? Slope, right. So it is an average, but it's a slope when we talk about these functions. And Mr. Ali can attest to this. If you plan on taking calculus, you got to understand average rate of change, right?
Yeah.
Okay. You don't, again, not everyone has to take calculus, but if you want to take calculus, you really, really, really need to hold on to this. That's one of the reasons why I'm making sure we hit this lesson before we end this unit. So average rate of change, we'll also use it in the future lessons. But remember, when we say f of b minus, and so this is the proper notation. This is what you will see me say. But when we say f of b, what does f of b really stand for? y2, or my output, right? That's the output at d. This is the output at a, right? So I'm just putting the outputs, right? So I'm finding the output at b, and I'm subtracting the output of a, or y2 minus y1, divided by b is my input, so x2 minus x1. And so literally I'm just finding the slope between those 2 points, okay? This is also a part of that last check your understanding that I have for y'all. But there is this example in the book, and I'm going to have y'all practice one in a second, where they want to know what is the average, go ahead and pull this page out by the way, 200 something, who has theirs in order?
274.
Thank you, just kidding, 274. I don't know what this was, sorry. So page 274 is what you want, huh? Oh, that's what, okay. So page 274, please go to that page. There we go, we found it.
I found that different in there.
No problem. This is a little out of order.
Rip that.
Gotcha.
What is the
Oh.
the rest of it?
I'm all over it.
Okay, so what we want is the average rate of change for this function on the interval 3.25, comma 4.25. So notice this is my interval that I want to find that average rate of change over. So 3.25, is that going to be my A or my B? You think so? I'll be honest.
A would be first.
It would be A, but honestly, doesn't really matter a ton. It'll work out the same either way, but why would it make sense that this is A? Not just because 4.25 is the bigger number, 100%, but I would just say because it's alphabetical, minimum to maximum. That's why we use A and B like that, because it's alphabetical. That's it. Okay, so you don't have to sweat it a ton. It'll work out the same either way, but using the formula, f of B minus f of A. So remember, what that really is just finding is the change in the outputs. So change in outputs divided by the change in inputs. Yeah, all right, there we go. So how could I rewrite this top up here? F of what? Okay. Now just be aware, if you do 4.25 first here, what do you have to do first down here? Which one? 4.25. F of B and B. F of A and A. It has to go in that order, otherwise you'll get the opposite, right? So if it's supposed to be positive, you get negative. If it's supposed to be negative, you get positive. Okay, so minus f of 3.25 divided, and then minus 3.25. Now, denominator, that's nice and easy. What's 4.25 minus 3.25? 1. Now, how am I going to figure out f of 4.25 and f of 3.25?
Don't get the graph.
So there's two options, right? If I have a graph, I can just look at the graph, can't I? And what if I had the equation? What would I do?
Work it out.
What do you mean by work it out? That's so vague.
Plug in 4.25.
There we go. Like their inputs, substitute them into the equation to get the outputs. So that's why I bring up inputs and outputs so much. So don't forget, all it is I'm looking for the change in the outputs. So I substitute my inputs in to get my outputs out. Okay? So what is f of 4.25? Can I see that on the graph clearly? What's that output?
3, negative 500.
Not for 4.25. 4.25 is right here.
Oh,
0.
0.
Yeah. It's 0. Okay? And what's the output for 3.25?
Negative 500.
Close. Negative 600. Notice it's right between negative 400 and negative 800. So minus a negative 600. All right, so what's 0 minus negative 600?
Negative 600.
600. And when you subtract a negative, you end up adding. So 600 divided by 1. Now, I just thought about this, and this is actually something I need you to go ahead and start paying attention to and thinking about. These aren't just random numbers. What does that 600 represent? Where did that 600 come from? Huh? It is the y. Okay, keep going down that track, though. This is a real-world context. Look at your y-axis. What is that y? The profit of what? Thousands of dollars. So 600 what? 600,000 what? Dollars. $600,000 per one what? Per 1 year. So what is this actually saying? And this is important for the next lesson that we do to start next unit. And I need you to pay attention to this. This is a what? So on average, this company does what? Makes $600,000 per year, but be careful, is that always true? No, it's only on this, well, it's also only on this interval. Because I want you to think about it. Notice, like right here, my slope is positive or negative? Positive, right? But what about if I went from about year 1 to a year 3.25? Are they having positive sales then? Oh no, that's what? Negative. It's decreasing, right? So we have to pay attention to the context here, and we can't just think about it when we do average rate of change. We cannot just do it and say this is always true. So on average, was it Zorzansa or Zorzansa? Zorzansa has is it a profit or a loss? Has a profit? Well, and now we need to remember, it's not overall, I'm talking about specifically just for this region, right? So on average, Zorzansa has a profit of $600,000 per year for years 3.25 to 4.25. Now, I'm bringing this up right now, not because of what I'll actually be testing you on assessment, so don't sweat that, but this is going to help you at the start of next unit. So please hold on to this. We need to recognize that there is context here. So on average, Zorzansa has a profit of $600,000 per year for years 3.25 to, it's only for that domain. If you change the domain, everything changes, which we're about to actually see. So please make what notes you need to on that quickly, and then I want you to so we actually just did 1B and C. 1A, B, and C. So if you want to write any of those notes under A, B, and C, you can do that. But after you finish that, I want you to work on numbers 2 and 3, okay? So we did 1A, 1B, 1C together. Once you finish that, I need you to move to number 2 at your vertical surface. So take your notes first. You don't have to rush to get up. Be careful and make sure your stuff is in the right order. If you actually follow this, you get 300 minus negative 600, which is 900, divided by 2, which is positive 450. But what's the issue when I look back at this graph between years 1 and 3? What's happening between years 1 and 3?
Decrease.
It's decreasing, right? But this would indicate that it's what? Increasing, okay? So just one thing to be careful of, right? That's why it's important to pay attention to that order. If you had done it this way, where it was f of 1 divided by 1 and f of 3 and 3, then it still would have worked because it would have been negative divided by a negative. But that's, or a positive divided by a negative. But be careful about that order, okay? The next thing is, I want to talk about this right here. This is something to be aware of. We got to be careful with the interpretation. Because what originally we had here, and this is a, again, fantastic mistake to make, but it said Zorzansa had a $450,000 or negative $450,000 profit. We also could have just worded that as $450,000 what? Loss, right? Either one would have been perfectly acceptable. It's a negative profit or it's a loss for years 1 to 3. But actually, from year 1 to year 3, how much did they actually lose? How much? They lost $900,000. And so this is what I want to challenge you and tell you to be careful about is they actually lost $900,000. The negative 450 is the average rate that they lost at, right? And so I'm going to build this off of the discussion I had over here with Miles's group. And this is the final couple of things I would talk about and I would pay attention to. If you want to do your calculations without units in there, that's perfectly fine. But math exists for the real world, not just for math's sake. So math exists for the real world. So when you get that negative 900, notice how we wrote that as negative 900,000 what? Dollars. Then it was per what? 2 years. That's a slope. That's an average rate of change. And so when we do negative 900,000 per 2 years, when we simplify this, dividing everything by 2, we get negative $450,000 per what? 1 year. And so the average rate of change is $450,000 loss per year from years 1 to 3. That gets us up to the $900,000 loss. So please take the time to write the average rate of change with your units before simplifying. This is going to help you a ton with the lesson that we do tomorrow to start the next unit. Now, remember one, what are we starting tomorrow with? Demonstrating understanding. There are practice problems with intervals of increase and decrease and average rate of change at the end of the check your understanding. I'll work through some of those and post those videos to YouTube. I'll work through it during my planning. You have a couple of minutes to take notes, but pause 1 second for me. So, Peyton, if you turn this way really quickly. So, one, make sure you study for the demonstrating understanding. We got tests next week. One thing I do want you, Mr. Hobby is about to pass out a sheet of paper. If you don't want to be a part of it, that's perfectly fine. I don't know if y'all have noticed, but I do a lot of filming for class. Part of it is to post for YouTube. Part of it, though, is I was nominated for an award that I have to record for and submit a video where they analyze my teaching. Okay? So, one, I've been doing extra recording sometimes just to help y'all get comfortable with the camera. But a lesson that we are starting tomorrow, and then we'll work through a few lessons through next week, are ideally the lessons I want to use. So, if you could sign that sheet of paper or get your parents to sign it, you don't have to give consent, but tell me one way or the other, and I can make sure whether you're in the video or not in the video based on that consent. What I will say is this. Literally, no one is going to see it except for the 4 to 5 people that are analyzing my teaching, not analyzing you. So don't let it be something where you're like, oh, I don't want people to see me. It's never going to go on the internet. It's never going to get posted publicly. 4 to 5 people who are analyzing my teaching are who are going to see this. So please encourage your parents to give consent. Please give consent. It just makes things easier if I don't have to navigate those things. Okay, we got 2 minutes for you to provide or write any notes you need to. Nope, I want that chalk to stay there. So take whatever notes you need to. Please get your parents to give consent. This is just the generic one for the county system.
Done, Miss Kenny.
What's up?
You done?
Oh, hey guys, hey, listen, really quickly. If you want to add it, and I'll send out a message to parents, but under intended audience, it would be other. It's literally just the people analyzing me. Like, it's not gonna go out to the news outlets, it's not gonna go to the social website, it's literally just the people analyzing me. Okay? So if you want to put that into other, you can. Take whatever notes, take whatever pictures you need to. We have 2 people out there, that's why there's a couple extras.
Oh, it's too late.
Yeah.
Done, Miss Kenny.
I guess I could have put,
Go ahead.
yeah, so.